Hello everyone. Today we are gonna solve a GRE question. The question is 10 factorial is divisible by 3 to the power of x times 5 to the power of y, where x and y are positive integers. And the question is, which one is greater? Quantity A, the greatest possible value for x. Quantity B, twice the greatest possible value for y. As we know, 10 factorial is 10, 9, 8 to 1. Okay. And we want to know when 10 factorial is divisible by 3 to the power of x and x when x is maximum possible value. Okay, let's examine how we can determine how many times 10 factorial is divisible by 3 or 5. There are various methods to approach this. The first method is quite straightforward. We can simply count. For instance, 10 factorial is 10, 9, as we said, until 1. And it has 3, 6, and 9. So there are 3 factors of 3, but we should be careful because 9 has 2 3, so it is 3 times 3. So 10 factorial has 4 factors of 3. And to find how many factors of 5 there are, we can also count easily. We have 5 and 10. 5 and 10. So there are 2 factors of 5 in 10. Here is 2 and there is 4. So the quantity A is 4. The quantity B, we know that the greatest possible value for y is 2, and twice of this measure is 4, so they are equal and we should choose C. While this method works well for 10 factorial, it is not very suitable for large numbers because it can be time consuming and prone to errors. For example, when we want to determine how many factors of 2 are in 30 factorials, we must remember that 4, 12, 20, 25, 28 each contribute 2 factors of 2. And 8 and 24 contribute 3 factors of 2. And 16 contributes 4 factors of 2. So when we want to use this method, for example, 1, 2, 3 30 factorial equals to 1, 2, 3, we should consider all these numbers, and maybe this method is misleading or not good enough for calculation. The systematic method involves using the following formula. Number of factors of p in n factorial is n factorial n over p p n over p to the power of k, and k is from 1 to infinity. So what does it mean? First, we should consider that the bracket notation indicates the floor function. For example, 5 over 2 is 2.5, and since the bracket is a floor function, we can write it as 2. It eliminates the positive digits after points. Now let's see how many factors of 3 and 5 are in 10 factorial. The number of factor of 3 is is 10 over 3 bracket plus 10 over 3 to the power of 2 bracket 10, let's say 10 over 3 is 3.3, and it is 3. 10 over 9 is 1 blah blah blah, and it will be 1. 10 over 27 is 0 point blah blah blah, so it is 0, and other terms of this series is 0. So there are 4 factors of 3 in 10 factorial. And if we use this method to figure out how many factors of 5 in 10 factorial are, it will be 10 over 5 plus 10 over 25. It is 0 and it is 2. So it seems easier method and more reliable. For example, in the example I just said, 30 factorial, we want to know how many 2 factors of 2 are in this number. Factors of 2 in 30 factorial. We have 30 over 2, 30 over 4, 30 over 8, 30 over 16, 30 over 32, and this is 0, and other terms will be 0. It is 15. It is 28 over 4 is 7, so it is 7 blah blah blah. We need only 7. 30 over 8, it will be 3 blah blah blah. We need 3, and it is 1. So we have 26, 2 in 30. I hope you enjoyed solving this problem.